While working on the classification of elements, a Russian scientist Mendeleeff found that when elements are arranged in the order of increasing atomic masses, the elements with similar properties occur at regular intervals. Based on this observation, Mendeleeff gave a periodic law in 1869. According to Mendeleeff's periodic law, the properties of elements are a periodic function of their atomic masses. Mendeleeff's periodic law means that if elements are arranged in the order of increasing atomic masses, then the properties of elements are repeated after regular intervals or periods. Students, Mendeleeff arranged all the then known elements in the order of increasing atomic masses in horizontal rows in such a way that elements having similar properties came directly under one another in the same vertical column or group. There were 7 periods, that is horizontal rows, and 8 groups, that is vertical columns, in the original periodic table given by Mendeleeff. Out of 8 groups, 7 groups are of normal elements and 1 of transition elements. Noble gases or inert gases were not known at that time, so there was no zero group in Mendeleeff's original periodic table. The elements in each group were similar to one another in many properties. The similar properties of the elements were repeated periodically after every 7th element. Gaps in Mendeleeff's periodic table. Dear students, in the classification of the then known elements, Mendeleeff was guided by 2 factors. Number 1, increasing atomic masses, and number 2, grouping of similar elements. Mendeleeff left some gaps in his periodic table in order to make sure that the elements having properties fell in the same vertical group. These gaps were left for the elements not known at that time. Mendeleeff thought that these elements would be discovered later on and even predicted the properties of these. And then unknown elements by studying the properties of the neighboring elements. The missing elements of Mendeleeff's periodic table was discovered later on, and their properties were found to be very close to those predicted by Mendeleeff. For example, he found the properties of titanium, that is denoted by Ti, similar to that of silicon, denoted by Si. There was a gap below aluminium in his periodic table. He predicted that this element would be discovered later. After 5 years, this element gallium, denoted by Ga, was discovered. Its properties were found similar to boron and aluminium as predicted by Mendeleeff. Now let us discuss about the merits of Mendeleeff's periodic table. The periodic table was of great help in the study of elements and their compounds. Some of the merits of Mendeleeff's periodic table are given here. Number 1. In his periodic table, the elements are classified on the basis of atomic mass. Number 2. Mendeleeff's periodic table left proper gaps in the periodic table for the then undiscovered elements like gallium, denoted by Ga, scandium, denoted by Sc, germanium, denoted by Ge, and so on. When a whole new group of elements called inert gases was discovered, it got a place in the periodic table. Number 3. Mendeleeff's periodic table could predict the properties of several elements on the basis of their positions in the periodic table. Number 4. Mendeleeff's periodic table could predict the errors in the atomic weights of some of the elements on the basis of their positions in the periodic table. For example, the atomic weights of the elements like gold, denoted by Au, and platinum, denoted by Pt, were corrected in this way. Anomalies or defects of Mendeleeff's periodic table. Students, Mendeleeff's periodic table was of great help in the study of elements, but a few anomalies could not be explained on the basis of his law. 2 anomalies or defects of Mendeleeff's classification of elements are given below. Number A. The position of isotopes could not be explained in Mendeleeff's periodic table. Isotopes are the atoms of the same element having similar properties but different atomic masses. If the elements are arranged according to atomic masses, the isotopes should get places in different groups of the periodic table. The isotopes were not given a separate place in his periodic table. B. Some elements were placed in wrong order of atomic masses. Students, in contrast to Mendeleeff's suggestion, some of the elements with less atomic mass were placed later. For example, argon is an inert gas and it is to be grouped with inert gases, whereas potassium is an alkali metal which should be grouped with alkali metals. In doing so, argon with higher atomic mass of 40 comes first, and the potassium with lower atomic mass of 39 comes later. Mendeleeff's periodic law does not explain this abnormal situation. C. Alkali metals and other metals like copper, gold, and silver were in the same group. D. There was not a suitable place for lanthanides and actinides.